Hello and welcome back. This is a video over the 6.3 notes, and this is a section about area. Okay, so we're going to find the area of rectangles and squares, parallelograms, trapezoids, and we're going to solve some applied problems on how to calculate area. Okay, so let's take a look here, and let's just talk about what area is. Area is the amount of space. Okay, so the amount of two-dimensional space that something takes up. All right, something takes up. All right, and so what often we talk about, when I think of like area, I think of like the amount of carpet that you would need to fill a room. I think about a painting or a picture on the wall or something like that. So the one thing I want to talk about here with area is, and let's just go through some of the formulas for like a rectangle and a square. So a rectangle, let's just draw a little picture of a rectangle here. A rectangle has 4 right angles, has 2 pairs of congruent sides, okay, and we'll call this the length and the width. The area formula that I have for a rectangle is that we take the length and we multiply it by the width, okay? And so thinking about this idea, okay, let's go back to what area is. So I wanted to introduce this concept first about what actually, this is your rectangle, okay, and taking this length and multiplying it by this width will give you the area. Okay, but let's talk about that for a second. Okay, let's say that you have a carpet that has, you have a room, and let's say that you've got a 10 by 15 foot room, okay? Now we're not calculating the distance around that room. We want to calculate how much of this space do we take up, okay? And so what we would do is this. If I wanted to find the area here, then that means I'm taking 10 feet times 15 feet, okay? Now, what the cool thing is that I can, manipulate this and I can reorder these things. Really what this means is I'm taking 10 times 15 and then I'm multiplying that by feet by feet. Okay, now 10 times 15 is just going to give us 150, okay? However, if I take feet times feet, that gives me what I call feet squared or square feet. Okay, same thing as the two-dimensional space, okay? That's the idea. And you probably hear that, you've heard that before, and we call this area a measure of square units. That's because when you take this length and you multiply it by this length, well, you're taking feet times feet, which gives you feet squared, okay? So anytime that we're dealing with area, whatever unit that you have is going to have to be squared, okay? All right, let's go ahead and move on down to a square. Okay, now a square is similar to a rectangle, and every square is actually a rectangle, but not every rectangle is a square. And what I know about a square is that all my sides are congruent, okay? All these have right angles, and what I know is that I'm just going to call this a side length, okay? Now, if this is a side length here, then that means that this is also a side length. So I'm going to call this S. Okay, so my area would be, I would just take S times S, and you can always do that. Or you could take area, and if you have S times S, that means that you have that S, that length S squared. Okay, I could draw 2's. They're hard to draw in this program for some reason. I don't know why. Okay. A parallelogram is similar to that of a rectangle. What you have is you have two opposite sides that are parallel and congruent. So these are going to be congruent, these are going to be congruent. And so what I have here is I'm going to call this length down here my base, but then the height of this parallelogram is the distance from one side to the other that forms a right angle, and I call this the height. Okay? And my area formula is going to just simply be the base times the height, and that's it. Okay. Now that's the same thing that we had for a rectangle. Okay. And what I want you to think about is this. Like if you, and I'm just going to draw. You don't need to write this down. I'm just going to show you. But if you have a generic rectangle like this, and let's say that you cut this rectangle from this corner to here. Okay. If you took this rectangle here, and then you cut that, and then you took this piece here, and then you moved it over to this side, then what would happen is you would create this. You would have this same rectangle over here. Okay? So then your figure would be like this, but you would just take this triangle here, cut it off, and add it to this side. So if you know how to calculate the area of this rectangle, it's going to be the same area as that parallelogram. It just looks a little bit different. Okay, so your formula stays the same. Okay, all right. So that's that. Now a triangle, and I'm going to draw two different triangles here. The triangle area of a triangle is going to be the base, okay, times the height. And the height is always the distance from the top of the triangle to the bottom that forms a right angle, okay? And so my formula for this is going to be area is equal to 1/2 times the base times the height, or you could write this as area is equal to base times height divided by 2. Same thing, okay? That doesn't matter. All right, now what if you have a triangle that looks like this? All right. And let's do this and have it kind of go up like that. All right, looks a little bit weird. This length here is still my base, but my height is the distance from the very, very top of my triangle all the way down to the bottom, okay? And that's the height. All right, and we would use the exact same formula as we did here, okay? All right, the next one is a trapezoid. Okay, a trapezoid is a weird looking figure, kind of weird like how I look, but I'm going to draw this figure like so, okay? And when I draw that figure, I have a couple different measurements here. I have this length here, which I will call my base, and I'm going to call that B sub 1. This length here is my second base, B sub 2. The distance from the top line down to the bottom line that forms a right angle is my height, okay? And the formula that I would use for the area of a trapezoid, area would equal 1/2 times the height times base sub 1 plus base sub 2, okay? Now, I don't really like that one. I prefer this one. I prefer using area is the height divided by 2 times b sub 1 plus b sub 2, okay? And those are the ones that we're going to use, okay? So these, we do need to know these by heart and know how to use them and all that. So let's go ahead and calculate the area of each of these figures. And the first thing that you'll notice is that the first 6 are going to be relatively easy for us to do, the first 7, but these last 2 are going to be a little bit tricky, okay? Okay, so let's just jump right in here. And the first example should hopefully kind of clarify, you know, what the concept of area really is. And what I have is I have a rectangle, okay? And this rectangle is a 3 by 4 rectangle, okay? So if I wanted to calculate the area of this, Okay, I'm going to call this my length. Okay, and this my width. So this is length, that's my width. So area is equal to length times width. What I know is that my length is equal to 3 centimeters and that my width is equal to 4 centimeters. Okay, now if I take this and plug it into my formula, I end up getting that my area is equal to 3 centimeters times 4 centimeters. Okay, so my area is going to be 3 times 4, which gives me 12, and then centimeters times centimeters gives me centimeters squared. Okay, so I am showing a lot of steps and showing a lot of work here. You know, I would, if I were you, you know, kind of depends on how well you're able to do this, but you know, if you just want to write this step down, that's fine. Okay, as long as you know your formulas, that's fine. Now this is 12 square centimeters. Okay, and I want you to think about how I said that. 12 square centimeters. How many little squares do I have in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square centimeters. That's how we get that. Okay, so really what we're doing is we're cutting all of this into squares and we're asking, okay, how many squares are there? All right. All right, let's jump over to the next one. And this is a square, okay? And the reason why I know that is because these two consecutive sides here are congruent. They're both 9 millimeters. All right, so that's an indication that you have a square if they're next to each other. All right, so then therefore all the other sides are going to be 9 millimeters. So my area formula is equal to side squared. Now my side length is equal to 9 millimeters, okay? So if I plug this value in for S, I get that my area is equal to 9, oops, let me do this, okay, is equal to 9 millimeters squared. So my area is going to be equal to 81 millimeters squared. Okay, 9 times 9 is 81, and I get that. Okay, so not too bad. As long as you know your formulas and know how to identify those side lengths, that's fine. Okay, on this one, my area formula, this is a parallelogram. My area is equal to just my base times my height. All right, so here's my base, and here's my height. Notice how it makes a right angle. Okay, so base is equal to 7 kilometers. Okay, your height is equal to 5 kilometers. So then our area is equal to 7 times 5. All right, so my area is going to be 35 square kilometers. All right, so not too bad. Okay, as long as you know know what you're doing, shouldn't be too bad. All right, on this one's a little bit interesting because you're not readily given. You know, here's your base length of 1.2, but then your height is the distance from the very top of your figure down to the bottom. Okay, so your formula, area is equal to base times height. Your base length is equal to 1.2 meters. Okay, your height is equal to 6 meters. All right, so your formula here is area is equal to 1.2 times 6. So if I do 1.2 times 6, that's going to give me an area of 7.2, and this is going to be meters squared. All right, and that's what we're looking for. All right, and that's it. Okay, on the next one, we have triangles. Okay, so I want to talk about this length here is my base, but my height is this length here. All right. Now, I prefer to use the formula just base times height and then divide all that by 2. Okay. My base length is equal to 9 meters. My height is equal to 6 meters. So if I plug all this in, my area is equal to 9 times 6, and then divide that by 2. Okay, so 9 times 6, that's going to give me 54. All right, and if I divide that by 2, ooh, what's that going to give me? I think 27? Ooh, yeah, 27. Okay, so my area here for this figure is going to give me 27, and this is going to be square meters, so meters squared. Okay, and that's what we've got. All right, the next one is one of those that we kind of talked about, and I said, all right, well, make sure we label our base, our bottom piece, but then we need to be able to label our height, which is the distance from the top down to the bottom. All right, so then the area, okay, I'm still going to do base times height divided by 2. All right, but my base is equal to 6.25 centimeters. Okay, my height is equal to 5.5 centimeters. Okay, so then my area is going to be 6.25 times 5.5, and then we're going to divide all that by 2. So let's do 6.25 times 5.5, and that's going to give me 34.375, and then we're going to divide that number by 2. Okay, so if we divide that by 2, that's going to give us an area of 17.1875 centimeters squared. Okay, and that's my area. All right, so yeah, those, not too bad, okay, on those. Let's take a look at this one down here that's a trapezoid. And so let's take a look and let's identify what our formula was for this. Area is going to be equal to height over 2 times b sub 1 plus b sub 2. Okay, now here's my b sub 1 is 18. Okay, 12 was b sub 2. Okay, my height is 7 centimeters. Okay, so let's plug all this in. All right, and evaluating this can be a little tricky sometimes, but let's just go through this. All right, so area is equal to height, which is 7, okay, over 2, times b sub 1, which was 18, plus b sub 2, which is 12. Okay. So if, what I want to do is I want to do what's inside the parentheses first, and that's 18 plus 12, and that's going to give me a total of 30. So I've got area is equal to 7 halves, and then times 30. Okay, now 7 halves, well, let's do this, all right? Let's convert, if we've got to do 7 halves times a number, let's do 7 halves times 30 over 1. Okay, and we'll just multiply across. So 7 times 30 gives us 210, and then 2 times 1 is just 2. So 210 divided by 2 is going to give me 105, so 105 centimeters squared. So it all, this, a lot of these guys is just you plugging these numbers into a formula and then your ability to evaluate and get that number. There's a number of ways of doing this, and I encourage you to kind of like, be like, hey, I have a different idea. Then pursue that idea. If you get the same answer in the end, then it doesn't matter. I don't care. But we just want to make sure that we're getting the right answer. All right, let's take a look at this one. Now this one's weird because we don't have a set, distance or a set formula for this. Okay, and what I notice about this is that I have a big rectangle, okay, 11 millimeters by 12.5 millimeters, and then I have this smaller rectangle here that's created from this missing space, okay, and it's kind of hard to see, all right? But so, what I don't have a specific formula for this, but what I do know is this. If I wanted to find the area of, and we'll call the yellow region in here the shaded region, okay, all this is what we're trying to find. So I'm going to call the area of the shaded region, so area of shaded region is equal to the area of the big rectangle minus the area of the small rectangle. Okay? So if I wanted to find the area of the big rectangle, okay, so let's do this. My total area is, so the area of the shaded region, let's do the area of the big rectangle first. That's an 11 by 12.5 millimeters. So let's do 11 times 12.5, okay? This right here is going to give me the total area of the thing, okay, of the rectangle, the big rectangle. Okay, but then we need to subtract off this area. Now what I know is that the horizontal distance here is 5 millimeters. My question is, what's this distance? They don't really give it to us. However, we do know that the total length is 11. Okay, check this out. So if my total length is 11, okay, and if I subtract off a 3 and a 2 from that, so minus 3 minus 2, I end up getting a length of 6. So the length from here to here is actually going to be 6 millimeters. All right? So that's going to be the area of the small one. Okay? It's going to be a 6 by 5. So, you know, we have this area here. Then what I'm going to do is I'm going to subtract off 6 times 5. Okay? So if I do 11 times 12.5, that's going to give me 137.5 millimeters squared. And then I'm going to subtract off 6 times 5, which is 30. Okay? So if I take 137.5 and subtract off 30, that's going to give me an area of 107.5, and this is millimeters squared. Okay, notice how I'm not like putting my millimeters in on every single step. Okay, on all this. I don't really do that. At the end is when I put it in. And if, you know, I just make sure that if I'm dealing with area that I have some sort of square unit. Okay. All right. Let's do this one, this last one on this page. And so what I have here, this one's a little bit weird. What I notice is I actually have two trapezoids here. Actually, no, this isn't a trapezoid at all. Okay, what I notice about this is I have a big rectangle, okay, and then I have two little smaller triangles that I could subtract out. So this one, if we were to find, you know, area of shaded region, means that I would take the area of rectangle, area of big rectangle, and then subtract off area of two triangles. Okay, and that's my symbol for triangles. Triangles, okay? I don't need to write out triangles every time. Okay, so what I know about this is that I need to find some dimensions here. What I know is that the area of my rectangle is going to be a 6 by 12, okay? So we can go ahead and just write that part down here. The area is going to be equal to 6 times 12, but I need to subtract off the area of these little triangles here. Now what I know, I don't know the dimensions for all these. I do know that my base length here is going to be 3 inches, okay, is going to be 3 inches. But what's this vertical distance here? Okay, and what I know is that the total length is 6 inches. And the length from this tip down here down to here is going to be 4 inches. Okay, so what would have to be left remaining? And what that would be, it would be 6 minus 4, and this left over would give me 2. All right, so the length from here to here is going to be 2 inches. Okay, so let's go ahead and write out the formula for that. Let's do 2 times 3, all right, and that's the base times the height, this 3 times this 2, and then we'll divide that by 2. Okay, and then let's go ahead and let's find the area of this triangle, Okay, now here's what's interesting. This whole thing is 6. This little spot here is 2. That means that this part would have to add up to 6. So this plus this need to add up to 6. So this part here is actually going to give me 4. All right, so this length, and I'm just going to color that in blue here and call that 4 inches. Okay, the other thing that I know is that this whole thing is 12, okay? This length is 3, this length is 3, this length is 2, meaning that this whole length from here to here is 8. Okay, so 8 plus what gives me 12, and that answer, folks, is 4. Okay, this is 4 inches. All right, so now what I want to do is I want to take 4 times 4 and then divide it by 2. So I'm going to do minus 4 times 4 and then divide it by 2. All right, so let's actually do the math here. And let's do area is equal to 6 times 12. 6 times 12 is going to give me 72. Okay, minus 2 times 3 is going to give me 6 over 2, minus 16 over 2. So my area is going to give us 72, minus 6 over 2 is 3, 16 over 2 is 8. So I've got 72 minus 3 minus 8. 72 minus 3 is going to give me, what is that? 72 minus 3 is going to give me 69, and then subtract off an 8. So subtract another 8 from that, and that's going to give me an area of 61, and this is inches squared. Okay, these last two problems are pretty tricky, guys. All right, there are other ways, but these would be the easiest ways to do them. So, you know, that's kind of how I have to think about it. So, all right, let's take a look at the next page. Let's look at some application problems. All right, let's take a look at this first one on the next page. And it says, Becky's rectangular swimming pool measures 27 feet by 14.6 feet. Okay, and that's the distance around the swimming pool. She likes to relax while floating in the inflatable mattress, which measures 6.5 feet by 2.5 feet. Okay, and it says, what area of the pool is left around Becky so that her nieces and nephews can play in it? So what we want to know is, if you have the area of the pool and Becky's on the inflatable mattress, how much area is left to play in? Okay, and so what I want to do is I want to find our area, we find the area of the pool, minus the area of mattress. Okay, so let's do this. For my formula, I'm going to do 14.6 times 27 minus 2.75 times 6.5. Okay, so this one isn't too bad. All right, so let's do 14.6 times 27, and that's going to give us 394.2 minus 2.75 times 6.5. It's going to give me 17.875. All right, so if we subtract these two numbers, 394.2 minus 17.875, that's going to give us an area that's remaining as 376.325. Okay, and this is going to be feet squared. All right, and that's it. Okay, let's take a look at the next one. Okay, on this one says that Maravine is planting a wildflower border around 3 sides of her backyard. Pretty cool. Okay, as shown in the figure. All right, so and this is that little strip that we have right here. So this strip of what looks like dirt on this picture is going to be where the wildflowers will go. And she's going to use wildflower mats, so she's going to put these mats on there to seed that border. Okay, each mat covers 7.5 square feet and costs $4.99. So the first thing we want to do is we want to figure out what's the area of this border. Okay, Then we're going to have to determine how many wildflower mats that she'll need to get. And then we'll have to figure out the total cost of getting those wildflower mats. So, pretty cool problem. I like this one. This one's good. So, what I notice here is that this length here, this long length, is 40 feet. And this is 60 feet. Okay, so the total area is a 40-foot by 60-foot plot of land. Now, the distance from this fence all the way to the wildflower border is 38.5 feet, and this distance here is 57 feet. So we're going to take the area of the whole thing, and then we're going to subtract out the area of the grass on the inside to leave us with the area that's left over for the wildflower border. Okay, so let's do this. To find the area of the border, and let's write that out, and let's do area of border, okay, and that's going to be equal to the total area, equal to total area minus the area of grass. All right, so let's put A for the area of the grass, or area of the border, and let's go through. And so the area of the big one, of the big plot of land, is 60 foot by 40 foot. So we're going to multiply those two numbers together to get the area of the big one. So we're going to do 60. All right, so we've got 60 times 40. And then we're going to subtract off the area of the grass. And the grass is a 38-foot by 57-foot piece of land. And so we're going to multiply these two numbers together. So 38.5 times 57. So 38.5 times 57. All right, so let's actually do 40 times 60. And that's going to give us, I believe, 2,400 square feet. And that's the case, so we've got area is equal to 2,400 minus, if we do 38.5 times 57, that's going to give us an area of 2,194.5 square feet. Okay, if we subtract those from each other, that's going to give us an area left over of 205.5 square feet. Okay, and that's the area. And this is the answer that we want for part A. What is the area of the border? Okay, so I came in here and put that in for A. Okay, so now that I know that it's 205.5 square feet, I want to know how many wildflower mats we need to complete the job. So here's my logic, and here's what we have to do. This is a little tricky, but I'm going to take the total square feet, all right, total square feet, all right, for the flower bed, and then divide it by 7.5 feet squared, okay? And the reason I do that is because, you know, they gave us that information here, that each mat covers 7.5 square feet. So if I take the total square feet and divide it by 7.5, it'll give me the number of mats that we'll need, okay? So if we plug that in and do 205.5 divided by 7.5, then that's going to give us, that will get 27.4 mats, okay? Now the problem is that you can't buy 0.4 of a mat, okay? Because if you buy 27 mats, that's not going to be enough, okay? You're going to have this little space left over, and you're, and so you're going to have to, you know, either cut that up or do something. So you would need to get an extra mat, all right? So this is a little bit tricky, but you're going to have an, 28 mats is going to be your answer that we'll need to put down, okay? And that's for part B. Okay, now we want to know what the total cost is going to be. So if we have 28 mats and they're $4.99 per mat, all right, so on part C, you know, if we take 28 mats and multiply it by $4.99 per mat, all right, then we'll get $139.72, okay? And that's what we have to do with those two numbers. So, yeah, I hope this helped out. I hope you enjoyed this video. You know, this is the type of problem where, you know, you guys have maybe encountered something like this before. It's not too far, maybe not the one where you wonder how much area is going to be left to have your nieces and nephews be there. But for a project like this where you're building something, you know, this kind of math is very useful. So hope you enjoyed the video, and we'll see you soon. Thanks a lot. Bye.